what we're actually going to look at is when you need to form and solve a quadratic equation to solve a particular problem. Okay? So this will kind of be the final step. It's called modelling, where you fit a function to it and you solve it. Right? So in the textbook, I'm currently on page 434. So I'm going to go through example 7 on that page, and then there's some more questions. We could do another one if you want. But it's all about being given a word problem and then forming an equation to solve it. So, are you there? I'm on the blue box, or the purpley blue, or whatever. So it says a gardener has 16 metres of fencing to section off a rectangular area of 15 square metres. Determine the constraints on the dimensions of the rectangle and find the dimensions of the rectangle. Okay. So, sounds quite a complicated question. It might scare you off to start with. Okay. We have to take it step by step. So it says the gardener has 16 metres of fencing, okay, and we have a rectangular field, and the field is 15 square metres. Yes, ma'am?
Is the fencing 40 meters?
A gardener has 16 metres of fencing. The blue box.
I was looking at problems.
You're looking at?
Problem solving. It's like the
That's what I said. I'm doing example 7, blue box. Okay. So we've got to come up with a way of expressing this in a formula. Okay. Has anyone got any ideas as to what we could do? Okay. Well, I'm probably going to do stuff that you kind of already know. So what's the area of the field? How would you work that out?
area.
It's a rectangle, so length times width. Okay? It's length times width. So we know that the length times width has to equal 15. Right? What else do we know? Not going to write any of this? No? What else do we know? Anything? Next? The amount of fencing that he has. Could we make any further statements there?
Well, I was going to say that we know that the top and the bottom are the same lengths.
Okay, yeah, could we, you're right, aren't you? So that's length as well, that's width. Using, I think Darius pointed out that we've got 16 metres of fencing. Is there anything we can, any other actual statement with numbers we could say? Frankie?
Well, we know that 3 times 5 equals 15, and that would, the 3 would be the width. And
so you kind of jumped in there because it's an easy question with a solution, yeah. But can we make a, you are actually, I think, saying what I'm looking for just after you've worked something out. What constraint is being asked to put a constraint on? What has to be the case? Yeah.
Length, 2 length plus 2 width must be equal to or less than 16 meters.
Yeah. All right. So we do less than or equal to 16 meters. What we're going to do though is I'm going to simplify it a bit and say we're not going to worry about the less than. You are correct. must be less than, but what we're going to do is we're just going to keep it as equals y in this case.
Because we can. Oh wait, no, never mind.
Go on, what were you going to say?
Well, I was gonna say that we could single out the 2L and the 2W, but that wouldn't work.
No. But why can I do? Why would I do equals and not less than? Yeah.
Because the fence is 15 meters, and if it was less than 15 meters, 16. And if it was less than 16, then we would have to. We
Well,
would use too much fence. Or
No,
too little
less than
fence.
two. Well, I guess that's the thing. I've got 16 metres of fence. I might as well use it all. Right? Very, you were correct in saying less than 16. I could use less than 16 metres of fence, but why would I in this case? So I'm just going to say I've got 15 metres of field to cover, and I've got 16 metres of fence. Now, something else that we've already said is it's 2 L's, 2 W's, they're the same. So can I simplify this a little bit and say that 1 L plus 1 W must equal 8? Make sense? Now the reason why I wanted to do that is because having lengths and W's doesn't help me solve it, because L and W could be anything. Okay? So what I need to do is I need to put everything in terms of one variable. So for instance, let me know if you don't understand why. I am going to choose my width. It doesn't matter which, I can do my length or width, but I'm going to call my width x. Okay? Any ideas what I would call my length? I could, but then I've got two unknowns, just like length and width. What I want to do is only have one unknown. And my length is determined by the width, no? Why is it determined by the width? Yeah?
Because the width plus the length has to equal.
Exactly. If you look at this thing here, length plus width has to equal 8. So if I choose a width, length is determined for me. It's not a choice. Okay? I know they have to add up to 8. Otherwise, I'm not going to have a rectangle. Yeah?
So would it be 8 minus x?
Yeah, so if I rewrite this, I've got width, if I do length, I've got the length is 8 minus whatever I choose the width to be. So actually, in terms of x, I could use it as w. I'm using x to represent it because we're used to that. My length is actually 8 minus w. And that's just set because that's what it has to be. Oh, sorry, not w, is it? Yeah, 8 minus x. That's set in stone. If that's x, that has to be 8 minus x. Right? So then, I know I've got 15 square metres of area. Can I set up an equation to work this out then? If I put this in brackets, it's always useful because we've got two parts to it. Matthew? Yeah. Right, how do you find the area of a rectangle? Length times width. Can we go back up to this length times width? So instead of length times width, we can do
8 minus
x times, sorry, I'm doing it the other way around, you're right. But I'm going to do x times 8 minus x. That's where the brackets come in. And what does that equal? 15 is the area. Okay? Okie doke. Yes?
After that, could you expand it?
Yeah, we could.
And
Do you want to? Why would you want to?
So you could use it as a quadratic function.
Do that? Could we not use it as a quadratic function here?
Could, I think.
So for instance, we've used three different forms of the quadratic equation. This is the what form? Quadratic. People don't normally get this question because they normally have to do something to get this form. What form are we in without actually having to do something? This is factorized form. Okay? So normally this is what happens. We've got, remember factorized form with something times something? Alright, and that's what we've done. So we've got it in factorized form. So this is where I can now say, what are the limits for x? So x being the width. So I can state the boundaries of what x is allowed to be.
X must be less than 4 but greater than 0.
Why less than 4? I get the greater than 0. Okay? Because 0 times something would make 0, and that isn't going to give me 15.
Would it be less than 4 because it has to be greater than the width, or less than the width, and I mean it has to be less than the length, and
Well, length and width are all a bit kind of, we can swap those names. If the width becomes wider than the length, then we can call it length and width. If you think that's why we call it x now, that could end up being longer, couldn't it? So what actually could x not be?
8.
8. Yeah? Must be less than 8, because if x was 8, again we'd end up with no area, yeah? Right. So, we could expand it as well, so let's write it in standard form. I'll leave you to do that. Go for it. So what do we end up with?
Negative 8 squared plus 8x
Negative 8x squared plus 8x
equals
equals 15. That's not quite in standard form yet. Kenzie? Yeah. So we would want to go negative x squared plus 8x minus 15 is 0. Okay. There is actually another way to do this. Not another way, but maybe a slightly nicer way to see it. Done?
8x minus x squared.
I see what you've done. You've moved the x squared so it's within it. Normally we want to write the highest power first. So we put the x squared, then the x, then the constant. But I do see why you're saying that. You put so you don't have a negative sign. I can actually get rid of the negative in front of the x. Well, not get rid of it, but I can do something with it. There's two ways to think about this. What if instead of minusing the 15, I add the x squared and then subtract the 8x and put it on the other side? So I have 0 equals x squared minus, catch up, plus 15. Okay, see what I've done there? So rather than subtract the 15, I've added the x squared, subtracted the 8x. I can get the same thing by multiplying both sides by -1. I'm sure we've talked about this before. what happens if you multiply something by -1? Jesse?
It becomes a positive, but it stays the same
Yeah.
number.
So negative x squared would become x squared, positive 8x would become negative 8x, negative 15 would become positive 15, and 0 becomes 0. So I end up with the same thing. Okay. So what I'm looking for now, alright, is now I've got my this form and I've got it equaling 0. What can I do at this stage now? Yeah.
Could you use the quadratic formula?
I could use the quadratic formula to solve for what x needs to be. But what should I try first? Try factorising it. Okay. So let's try factorising. Does this one factorise into 2 brackets? Yeah.
Yes.
Go on then.
X minus.
Oh, sorry. X minus and x minus. Must both be minuses. Yeah. It's actually quite easy. What multiplies to make 15? Go on. 5 and 3. Yeah. Got that? So we've got x minus 5, x minus 3. That equals 0. So what are my values for x then? 5 and 3. Now what we have to be aware of is if we get a negative value for x now, because we're applying it to this situation, we don't use it because a negative length or a negative width doesn't work. But just to finally interpret this result, what have we actually got here? What do these numbers mean? Yes. Well, x was actually the width, wasn't it? So I could have x is 3. What would the length be? 5. The other option, which you'll say is exactly the same option, was to do 5 and 3, no? If x is 5, then that would be 3. So there are actually, in this case, there is only one solution, which Frankie told us right from the beginning, because this one was actually quite obvious anyway. But yeah, 5 and 3. That's what the 2 options are. In reality, there is only one way, because we've now applied this to a real situation. Okay? So that's how we can solve a quadratic equation to find a situation like this. So what I'm hoping you'll do now is the exercise on the problem solving. Alright? You can have a look at those problems. Have a quick read. Is there any, would you like me to go through another one, or are you ready just to get on yourself? Get on.